All right, y'all. So I've been working since class ended on November 8th, 2021, trying to figure out why our data was getting so wonky. I think what it comes down to is the conductive paint that makes our conductors has all but dried up and it's cracking, and it's just meaning that we're getting conductors that are connecting and disconnecting and messing things up. We can try to do this lab next class, but I wanted to really quickly go through why it's stable and just make sure I can show you guys how to plot equipotential lines. Just as a reminder, we have a power supply. The positive of it is hooked up to this pin. The negative is hooked to this pin. We have a multimeter that's set up to measure potential difference. It's also hooked to the negative pin. So that means every time I touch the positive probe somewhere on here, it's getting me the potential relative to this terminal. So I'm going to quickly go through and get a few different equipotential lines. The first thing is to just try to find a random point. Let's go here. Let's do 10, 5. And that has a potential of 3.86. So 10, 5, I'm just going to plot here real quick. 3.86. So I'm going to try to find a few other points that also have 3.86 volts. And we'll connect those to make our equipotential line. The first thing we should do is try to find one between the 2 points. So that's like here, between 12 and 13, a little bit closer to 12. So there we are right there. I'm going to try to find symmetry-wise. Since we started below our positive charge, it makes sense to check above it. So we'll check somewhere up here. So that's right there, a little bit below 15. And we'll just kind of check towards the extremities, see if we can find it somewhere around here. Well, that was good luck. So like around 6 and 0. And we'll check somewhere up at the top. So somewhere around 5 up at the top, a little less than 5. So I'll bring my camera down here so y'all can see. And I'm going to draw basically a smooth curve connecting my different points. And that's my equipotential. Since I found it on this side, I'm going to check similar points on the other side and see if I can find something similar. So I'll bring my meter down so we can see it here. I guess I ought to check, if I checked below the positive, I should check below the negative. So that is 2.25 volts. And now I'm just going to run through and see if I can find other points along that. So we can see that I do have another equipotential line kind of symmetrical there. So I'm just going to try to throw in a few more, and I'm always going to check if I find it on one side, do I find it on the other? So you can see I found a pair of equipotential lines, which are circles around the two charges. So I think what we are going to continue to find basically are lines like this. And in the middle, we should expect to see a place where we get halfway between the potential of one pin and the other. We should get about 3 volts. And that's where the positive potential from this place is going to be canceled by the negative potential from that. So we can map this out and we can generate the electric equipotential lines that we expect to see from the theory that we talked about earlier. This is how you map equipotential lines and eventually electric field lines, since we know those are going to come out of the positive and into the negative and always be perpendicular to the equipotential lines that we're observing. I hope we'll be able to do this in class, but at least I hope you guys now can see what the process is.